Alright, in section 4.9 we talk about antiderivatives. Antiderivatives are basically what you're going to learn in Calculus 2. They're called integrals, but here we're calling them antiderivatives. All an antiderivative is a way in which to find the original function when you know the derivative. So you're going in the other direction. Instead of taking the derivative, you're reversing the process. So if you got some function f, the antiderivative we're going to call capital F. All right, thus the f prime equals f. All right. Now, if you let f equal x squared, then capital F is going to be 1/3 x cubed. But notice 1/3 x cubed plus 100 is also a possible answer to the function. And so you've got a whole family of formulas that can work for the same, can answer the same question. So 1/3 x cubed, when you take its derivative, you do get x squared. But whether you add 1, 2, or 3, or -1, -2, whether you add any constant to these functions, you still have a function whose derivative is x squared. So there's a whole family of antiderivatives of the original function x squared. And we call those 1/3 x cubed plus c for some capital C. So how do we find the antiderivative of sine x? Well, you think of what function when you take its derivative gives you sine x. Well, it's minus cosine. So f prime equals sine x, and so you can think of the general function as minus cosine x plus c. For b, what function when you take its derivative gives you 1/x? Well, it's ln of x. And you can actually use the absolute value around the answer here, and you don't lose any ambiguity with the original question. Ln of x equals 1/x no matter whether x is positive or negative. So this actually does give you 1/x. X to the n. Well, what you're going to find is when you use what the power rule is backwards, you're taking this exponent, adding 1, and dividing by that new exponent. So you add 1 to the exponent, and you divide by that n plus 1, and that's your derivative. And then here's your, basically this is your derivative function worksheet handout that I've given out before, but it's just going in the other direction. Right? X to the n and x to the n plus 1/n plus 1, 1/x, ln of x, e to the x, e to the x, b to the x, b to the x over ln of b, cosine sine, sine negative cosine, and so on. Notice you get your trig functions here as well. Sine inverse is 1/square root of 1 minus x squared. Tangent inverse is 1/1 plus x squared, and you got the hyperbolic as well. So they ask you to find the antiderivative for this function here. You want to simplify this part down first, so you write each part over x, and then you reduce that to 2x to the 4th, and you reduce that to 1/square root of x, or x to the negative 1/2. Now you're ready to take the antiderivative, and we know sine's antiderivative is minus cosine, and we know we add 1 and divide by that number, and we add 1 and divide by that number, and when you simplify that down, you end up getting this guy here in its final form, and it's also plus c. The plus c is used when you're talking about the general form. If they don't ask you to find the general form, you don't put the plus c in your answer. Alright, find f if f prime equals e to the x plus 20, 1 plus x to the second to the negative 1. Well, if you write that in this form, it's easier to see what this is. This is tan inverse. Right? That's just tan inverse is derivative. So when you do the antiderivative, you get tan inverse, and when you do the antiderivative of e to the x, you get e to the x, and you got to tag on that plus c. Now sometimes they'll give you a statement that will allow you to figure out what c is. So if you let x be 0 and the whole function equals -2, you plug in 0 for x and you let it equal -2, and then you can nail down what c is, and now you've found the very specific function, not the general function. Here they ask you to find the second derivative, and they give you two snapshots, two pictures of the function at given times. It's just taking the antiderivative twice. Right? So you take the antiderivative and you get this guy here, and it simplifies down to this. Okay, and then you do antiderivative again, and each time you do the antiderivative you tag on a new constant. So the first one you're going to tag on you'll call C, the next one you call D, and if there's another one you call E and F and G and so on. So if you want to nail down what D is, you let x equals 0 and let the whole thing equal 4, so you get D equals 4. So now you can plug 4 in there for D. And now use the other one, which was f of 1 equals 1, plug in 1 for x and let the thing equal 1, and you can figure out C equals negative 3. And so now you found the very specific function, not the general one. Alright, now what if they give you the first derivative and ask you to come up with the original function? Well, remember, where the first derivative is negative, that means you've got a tangent line that has a negative slope. So between 0 and 1, it's decreasing. And from 1 to 3, it's increasing because it's positive, increasing. And from 3 to infinity, it's decreasing. And so you can see where it's decreasing, increasing, and decreasing. And where it equals 0 is where you have a max or a min. Okay, and so you see you got a min and the max there at the 1 and the 3. And then where this thing has a max and a min at its peak is where this guy has concavity changes. So there you go. Now they talk about the most common derivatives functions that you should know about is position, and then velocity, and then acceleration. These are all derivatives of each other. Alright, so if they give you the acceleration function, you can take the antiderivative and find the velocity. And so you take the antiderivative, and then you get your answer, and you plug in v of 0 equals negative 6, and it allows you to figure out what C is. Now if you take the antiderivative of the velocity, you'll get the position function. And you got to use the point s of 0 equals 9 to figure out what D is. And once you figure out D, now you've got position, velocity, acceleration. Alright. Now note, acceleration is either 9.8 if you're talking in metric, or 32 if you're talking about in feet. That's the acceleration of gravity. And we're going to use that in this problem here. So they talk about they're throwing a ball upward at a speed of 48 feet per second from the edge of a cliff, and they're 432 feet above the valley floor. So find the height of the ground above the ground t seconds later. So acceleration is negative 32. So your velocity is negative 32t plus a constant. And then you nail down what C is because you know v of 0 equals 48. You know at time 0 it's going at 48 feet per second. So you can figure out what C is. And now you've got your velocity function. Okay, v of t equals this guy right here. Okay, and then you can plug in 0, set this thing equal to 0, and find out when the maximum height is, when velocity equals 0. And you can also take the antiderivative of that and find the position function. And you have to use the point where at time 0 you're 432 feet above the valley floor. So that allows you to figure out what D is. And so now you got the position function. Now they want to know when the ball hits the ground. That's when the position function, when the height of the ball equals 0. So you let this thing equal 0 and you get two answers. But a negative 3.9 seconds makes no sense. So positive 6.9 seconds is the answer you want there. Let's see, I think there's about 17 questions on WebAssign. So I'll just show them to you one after another, and you can pause it wherever you want. But these are the answers to the questions initially. Your question is going to be slightly different. Not much, though. Keep in mind when you go to take the antiderivative of x to the negative 1, it's real easy to say, alright, I'm just going to add 1 and divide by that new exponent. Well, then you're dividing by 0. So you got to catch yourself. When you have x to the negative 1, that's 1 over x. And we know the antiderivative of 1 over x is ln of x. So watch out when you get x to the negative 1.